All right, we just got done talking about rational exponents, where if I gave you 8 to the 1/3 power, we can take that rational exponent, we can convert it into radical notation, and really say that 8 to the 1/3 power is the same thing as the cube root of 8 to the first. Remember the silly thing, top dog goes in the house? I can then simplify it and say that the cube root of 8, or 8 to the 1/3 power, is really 2. So what if we have 8 to the 2/3 power then? What do you think that means? Well, if 8 to the 1/3 power means the cube root of 8 to the first, and top dog goes in the house, then 8 to the 2/3 power really means the cube root of 8 squared. So now my exponent inside is a 2 instead of a 1. So I can still use the idea that top dog goes in the house. And then I can simplify. Here's kind of the cool technique though, now that I have an exponent other than a 1 underneath. I could do it a couple of different ways. I could take that 8 and square it first. 8 squared is 64. And then take the cube root of 64. What times what times what? What number multiplied 3 times gives me 64? I got 4. Or what you could do is you could do the cube root of 8 first. I can take that 2 exponent, bring it out for a second, take the cube root first. What's the cube root of 8? 2, right? And then I can bring those squared back and say what's 2 squared? 4. If you notice, I get the same answer either way. So you can do the radical first and then the exponent, or you can do the exponent then the radical. One way might be easier than the other when we're asked to simplify. So kind of a cool technique showing you that it doesn't matter which one you do first, we should still get the same answer. That's kind of what this rule is saying. You can do underneath the radical first, or you can do the radical first and then the exponent. Let's use that trick to do a few problems. In example number 3, it asks us to write an equivalent expression using radical notation and then simplify. So they give us rational exponents, 27 to the 2/3 power. Let's go ahead and convert that into radical so we can figure out what this is equivalent to. Remember, top dog goes in the house, so my 2 goes underneath, and my 3 is my index. I then have the cube root of 27 squared. Now, you could do 27 squared, that's 27 times 27, which is a pretty big number, and then try to figure out what the cube root of that really big number is, or we can do it in a different order. It might be easier to figure out what the cube root of 27 is first. What number multiplied 3 times gives me 27? I got 3. Then I can take that 3 and square it. 3 squared is 9. That was a little bit easier than using really big numbers. Okay, what about B? 25 to the 3/2 power. Ooh, this one's a little bit different. You notice that my numerator now is the 3 and my denominator is the 2. But remember, top dog still goes in the house, so that 3 should be the exponent inside and the 2 should be my index. So really what I have now here is the square root of 25 cubed. You could figure out what 25 times 25 times 25 is. That's a really big number, and then try to figure out his square root. Or it might be easier to do it in the other order. Maybe we can figure out what the square root of 25 is first. That's easy, that's 5. And then figure out what 5 cubed is. That's better than 25 cubed, right? 5 times 5 is 25. 25 times 5 is 125. So using that technique helps me work with smaller numbers, so I'm not always having to work with such large numbers. All right, let's do example number 4 also in this video. It says here to write an equivalent expression using exponential notation. So let's go backwards now. If they give me the problem in radical notation, can I go back and write it as a rational exponent? Okay, well remember, I know it's silly, but top dog goes in the house. So if in the house is the 4, then that means my 4 is going to be my exponent and going to be my numerator in my exponent. So I can really say that the cube root of 9 to the 4th power is really the same thing as 9 to the 4/3 exponent. Top dog goes in the house. Okay, so look at B. If I have the 4th root of 7xy to the 5th power. Now remember, I can write the 5th power outside and do that last, or I could really say that I have 7xy to the 5th power all underneath the 4th root. Remember the rule says we can do the radical first, or we can do the exponent first. So I should be able to write it both ways. This might be easier to notice then that my top dog in the house, my inside exponent is the 5, and my index is the 4. So when I go to convert it to rational notation or exponential notation, I end up getting 7xy to the 5/4 power. Do you notice that I have parentheses? That's important because the whole expression of 7xy needs to be raised to the 5/4 power.